All right, so we are going to talk about the Chapter 2 follow-up. Should probably turn music off before my YouTube gets flagged for playing music that is not mine. All right. So the biggest thing to understand on problems that deal with percentages is that when we talk about a percent value of 100%, that is what you are supposed to have. That's the total, that's everything. It's a whole one. So if we relate an equivalent percent and decimal value, the decimal value of 1.0 is 100%. So when we look at A, 1.074, that's bigger than 1. It's going to be bigger than 100%. Now the trick that we said when converting decimals to percents, you might want to write this down. I was going to write the word, but I'm just going to do the symbol percent. To move decimal to percent value, we move the decimal 2 places right. So notice how in 100%, the decimal's right there. If I move from a decimal number, boop, boop, 2 places right, we get the percent value. So I do that here, and guys, I would draw it. Like I would literally draw it to give yourself the reminder of what the heck happened. And that becomes 107.4%. Questions on how that becomes 107.4%. The other way we can think of this is 1.074 over 1. To become a percent value, it needs to be over 100. And then whatever number is over 100 is our percent value. So if we multiply by 100 on bottom, that's the same thing that happens on top, and multiplication by 100 turns this into 107.4, and since that's over 100, it's our percent. Any questions on that? So I'm going to erase it to do the mixed number. For the mixed number, I just read this correctly. Do I have any volunteers to read this in the right way? Because I don't say 1.074. We can, but that's not the best way. You want to try it? 1 and... Yeah, we have to think about what decimal place do we end in, and it's the thousandths place. So it's 1 and 74 thousandths, because this is tenths, hundredths, thousandths place. So 1 and 74 thousandths. We do not need to reduce because it doesn't ask us to. Questions on 1A? 1B, Dana, are you getting anything done? Kind of looks like we're spacing out a little bit. So we start in percent. If I wanted to, I could write this as the percent over 100. Right? Because a percent means that number is over 100. But that's not really what we need. We need this as a decimal number. Well, wait. If we could move the decimal 2 places to the right to turn into a percent, how could we turn out of a percent? Like go the other way, 2 places to the left, right? If I have a percent number, and I want to get to a decimal number, we can just move 2 places to... Because guys, remember that 100% was 1. So what would 500% be? 5. So this is going to be 5.343. Right? If 100% is 1, it makes sense that 500% is 5. Does that make sense to us? So guys, sometimes I like to make math problems easier before I solve the actual problem. If 534.3% is too hard, just in your head, think about, what if I had 500% of something? If Domino's, they really need to pay me because I say Domino's a lot in these videos. But if Domino's shows up at your house with 500% of what you ordered, that's a great night. But it is 5 times whatever you ordered. 500% would be 5 times. And then if there's some extra, there's some extra. And as a mixed number, how do I read this right? 5 and what? 343. What decimal place do we end in? Yeah, thousandths again. I made these problems related on purpose. They both use that thousandths denominator. Questions on one at all? You feeling all right? Sweet. Sorry, you're just real quiet back there, so I got to check in with you. Oh, I need to copy question 2. So take a second, look at question 2. It's telling us to convert those fractions into the denominator that makes sense. Whoa, do something that makes sense. That sounds very mathy. Where did I find the follow-up? Oh yeah, it's a Word document. That's where it is. Why do we want the denominator to become a 10 or 100 or 1,000? What's the point of that? Because we want to become a decimal number, and decimals are all working in a base 10 system. Right? Decimals are working in a base 10 system. Deci, right? Deci means 10, or broken up by tens. So when we look at the denominator of A, is it easy for 4 to become 10? Not really. Is it easier for 4 to become 100? Yeah. So instead of thinking about, let's turn this into a denominator of 10, we kind of jump over that option and say, let's go with denominator of 100. How do we turn 4 into 100? Times 25. So we do the same thing on top, and 3 times 25 is 75. That tells us our percent value. Because if we're over 100, we have our percent value. Whatever number is over 100, that is your percent value. It also, if I read it correctly, tells me the decimal value. 75 hundredths is going to end in the hundredths spot, which is my second decimal place, which is nice because it's perfect. 0.75, it fits in nicely. We do the same thing with part B, but it's a little bit weirder, right? Because my numerator is bigger than my denominator. So how can 25 become 10? Well, it can't really, so we kind of skip that option. Let's make it 100. How's 25 turn into 100? Times 4. But on top, when we do that, we get 100 for hundredths. So guys, anything over 100 is your percent. So we know it's 104%. But crap, if my decimal number needs to end in the hundredths spot, but I have 3 digits. You want to tell me what to do with this, Daniel, since I told you need to do number 2? How do I fit 3 digits in where I only really have 2 spots? Did you say work back? Sorry, I couldn't quite hear what you said. Where should my 1 go, really, is what I'm wondering, of my 104? You're good to pass. I just wanted to make sure you were paying attention to what we're doing because you weren't writing it down, so get this stuff written down if you don't have it on your paper yet. Can't skip numbers. That 0 is important because it's in between there. If we start with the 4 here, you're close. Your idea is close. We still have to write 104.
That's what I was gonna say, but I thought that we didn't. I thought that.
You got real mad real fast. You're like, that's what I was gonna say. Yeah, it's 1.04. Right? That's why I left. Nope. So we just have to not put a 0 here, right? That we don't. What I was saying isn't really true, right? Which is you're allowed to call me out when what I say isn't true. It's not that I only have 2 spaces to work with. I only have 2 decimal places to work with. I just have to use the 1's spot. So I got to start in the 1 spot. I still have 104 here, right? But how we say it is 1 and 4. Guys, what we could have done in between, rewrite this as a mixed number. 1 and 4 hundredths. Because it's over 1 and 4 hundredths. That is 1 and 4 hundredths. If we look at C, this one feels slightly not so bad because 5 can turn into a 10. But here's the thing, don't fall into the trap. This is not 6%.
Is it
60, because I need to get 100 on bottom. So if we do that, we have 60 over 100. But when I go to write the decimal, I could have just used 6/10. Right? Because 6/10, 0.6. But guys, what if I use 60 hundredths? It's the same thing. Because this 0 actually doesn't matter because it's at the end. Zeros that are at the end doesn't actually matter. And then D, I forget what D was. 7/8. Ooh, one of the trickiest ones. 7/8. Now, one thing a lot of us are getting used to doing is if we can get the bottom to 100, that gives us our percent. And this is the last problem we're going to have time to do. So 8 to 100, if I check that in my calculator, do the division backwards, it's times 12.5, which gives me 870, 87.5? A decimal in my fraction is bad, but anything over 100 is your percent. So go ahead and write that out here. 87.5%. This fraction's not nice, but it tells us our percent. Now what is nice is if I want to bump this over 1 spot, I just multiply by 10 on top and on bottom. So this really becomes 875 thousandths. So guys, the decimal number that we need to have here, or we could get it from our percent. Right, if we bump this back, our decimal number is 0.875. We can do 3 and 4 tomorrow if we want, or people can come back during war or extensions or whatever. But yeah, I have war coming to my room, so we got to throw stuff away and probably get out of here.
One thing, if y'all wanted to try color guard, there's a color guard thing in the cafeteria. You can